All right, so the next thing we're looking at is divergency tests. And the divergency test. So the divergency test is a part of that, is a extension of that theorem in green that we learned earlier. The theorem in green says that if a series converges, the limit as n approaches infinity of the general term will be equal to 0. And we were also told that the converse is not necessarily what? True. That if a series converges, the lim as n approaches infinity of the general term is going to be 0. That is the theorem we learned earlier. The divergency test is a spin-off of that theorem. And the divergency test says that if the lim to infinity of the general term of a series is not equal to 0, then the series will what? Diverge. Example 5. And the idea then, therefore, is if it's not converges, if it's equal to 0, it what? Converges. If it's not, if it converges, it will be equal to 0. So if it's not equal to 0, it means that it must what? Diverge. All right. Now, the divergency test is going to answer a question of what? Convergence. We're going to apply the divergence test to show that this is divergent. And if this series is divergent, it means that it is not what? Convergent. So let's apply the divergence test. The divergence test that says that the limit as n approaches infinity of n over n plus 1 would be equal to the limit as n approaches infinity of n over n, n over n plus 1 over n. In other words, I'm dividing the numerator and denominator by the highest power of n. This is the limit as n approaches infinity of 1 over 1 plus 1 over n. Direct substitution, this is 1 over 1 plus 1 over infinity. This is going to be equal to 1 over 1 plus 0, which is equal to 1. So since this did not equal to what? 1, it means that the series what? Divergent. Because the divergency test says that if this is not 0, it what? Diverges. So therefore, n minus 1 to the n power of n over n plus 1 diverges. And is therefore not convergent. So next, we're going to look at the D'Alembert's ratio test. Now, D'Alembert's ratio test states that for a series of positive terms of the form from 1, the sum to infinity of un, I if the limit as n approaches infinity of the mod of un plus 1 divided by un is less than 1, then the series what? Converges. If it is greater than 1, then the series what? Diverges. If it's equal to 1, then we need to test further. So in example 26, we have a series that is of this form. And what we want to know is if this series converges. So let's find out using the D'Alembert's ratio test. First of all, UN is equal to 2 to the n minus 1 over 3 to the n, which is the same as saying 2 to the n over 2 times 3 to the n. UN plus 1 is the same as saying 2 to the n plus 1 over 2 times 3 to the n plus 1. So UN plus 1 divided by UN would be equal to 2 to the n plus 1 over 2 times 3 to the n plus 1 divided by 2 to the n over 2 times 3 to the n. This would be equal to 2 times 2 to the n over 2 times 3 times 3 to the n, multiply by 2 times 3 to the n over 2 to the n. Well, this cancels that. This cancels that. So it looks like what I'm left with is 2 over 3. So the ratio is 2 over 3. So the limit as n approaches infinity of the modulus of UN plus 1 over UN would be equal to the limit as n approaches infinity of 2 over 3. Now, there's no n in that n at all, so it's not affected as n approaches what? Infinity. So this is actually equal to what? 2 over 3, which is what? Less than 1. If it's less than 1, we're told that the series what? Converges. Since the limit as n approaches infinity of over is less than 1, the series converges. The series converges.